to a subset of lobe sensor node into a specific position in the field of interest. Okay, so mobilizer module allow the nodes to move or change its location to perform the required task. Okay. Another component is locating finding system. Location finding system. In some instance, the operation of the sensor node, as in some of routing technique, require knowledge of location. Okay, this node will be equipped with the module that is used to determine either the relative or absolute location of the node. For example, for absolute location can be obtained using GPS. Okay, so again, by using this component, each node can determine the relative or absolute location of the node. Okay, these are the components of wireless sensor node. عليكم السلام وجود عليكم السلام. Okay, can you hear me? Can you hear me clearly? Okay, thank you, Dua Shahab, thank you. Okay. The characteristics of wireless sensor network. Some requirements of wireless sensor network is a small size, large number, tetherless. Tetherless means without connection to the internet. Yes, without connecting to the internet, and low cost. These are some requirements of WSN wireless sensor network, and some constraints which are defined for the WSN is energy, computation, and communication. A small size. Employ low power CPU, radio minimum bandwidth and range. Um, okay, and also ad hoc deployment implies no maintenance or battery replacement. Okay, so again, the ad hoc uh, deployment implies no maintenance or battery replacement. Okay, so to increase network lifetime, no raw data is transmitted in WSN. So don't forget that we need a low power CPU and radio with minimum bandwidth for the WSN, because the power consumption of WSN is so important. Okay. I talk about the ad hoc wireless networks. Uh, a wireless ad hoc network, or VANET, is a decentralized type of wireless network. The network is ad hoc because it does not rely on a pre-existing infrastructure such as routers in wire network or access point in managed wireless network. Okay, so again, what is the difference between the ad hoc and some networks such as wire network? The ad hoc network does not rely on a pre-existing infrastructure. For example, in the usual network, some nodes are routers. Okay, so some nodes are access point. Okay, but in the ad hoc network, uh, uh, some some pre-existing infrastructure such as router in wire network or access point in managed wireless network uh, is not defined. Okay, and instead each node in ad hoc wireless network, each node participates in routing by forwarding data for other nodes. Again, each node each node participate each node participate in routing by forwarding data for other nodes. Okay. Ad hoc wireless network consists of large number of self-organizing SOT or mobile nodes that are possibly randomly deployed. And okay, in WSM, uh, the nearest neighbor communication are utilized between the nodes. And also in wireless connection, links are fragile and possibly asymmetric. Links are fragile and possibly asymmetric, and connectivity depends on the power level and fading and interference is high for omnidirectional antennas. Omnidirectional antennas because okay, each node can use the antenna. Okay, so the interference can be occur and between the radio uh, radio transfer. Okay, so the interference is high for omnidirectional antennas. Sensor networks and sensor actuator networks are a prominent example of ad hoc wireless networks. Um, Distinguishing features between WSN and ad hoc networks. Okay, I can say WSN WSNs are ad hoc networks uh, because the same as ad hoc network, wireless nodes that self-organize into an infrastructure-less network, but in contrast to other ad hoc network. Okay, I want to talk about the WSN, but the difference between the WSN and other ad hoc network are sensing and data processing are essential. Sensing and data processing are essential in WSN. WSNs have many more nodes and are more densely deployed and are more densely deployed. Hardware in WSN must be cheap. Nodes are more prone to failure. The in WSN network, okay, we need a large number of sensors, okay, and the nodes in WSN are more prone to failures, okay, so these hardware must be cheap. WSN operate under very strict energy constraint. WSN operate under very strict energy constraint. Okay, so some appropriate algorithm and topology and also hardware must be used in WSN and WSN nodes. WSN nodes are typically static, and the communication scheme are many to one. Yes, because in WSN you saw in some previous slide, in the first slide I think, you know there is one base station and some sensor nodes. Okay, and all sensor node must be sent the data, the sense data to the base station, data collected at the base station. So this communication scheme is many to one from nodes to the base station, rather than peer-to-peer, which is used in ad hoc network. Yes, Jeb. Yes, many nodes to one station. Okay, and also this is hierarchical, Shab. Okay, so this is possible. Many nodes to one nodes, and again other nodes to the base station. If okay, for example, please let me uh, stop sharing and share whiteboard. Um, Again, you can see many to one. Okay. Uh, this node can be the base station. Uh, this node can be the head of some nodes, and okay, again you can see this is the communication many to one. Okay, but in some levels, not one level. A peer-to-peer is used in ad hoc. In ad hoc, the peer-to-peer communication is used. Uh, okay, we can come back to the WSM. I say the lifetime is very important in WSN because the nodes are battery power. The nodes are battery power, and nobody is going to change the batteries. Nobody is going to change the batteries. So each operation bring the node close to this. Each operation brings the node close to this. Okay, so we need to control the operation which are done by the node, and we want to decrease the number of operations. Okay, so the lifetime is crucial for uh, WSN. Okay, so to increase the lifetime, we need to save energy. We need to save energy. Okay, some ways to save energy. Uh, First, sleep as much as possible. Sleep. Okay, each node must be asleep as much as possible. Acquire data only if indispensable, if it's necessary, acquire data. Use data fusion and compression. Use data fusion and compression. Okay. Do you know what's mean of data fusion? Okay, I can share. Okay, please let me to stop sharing and share uh, my screen. Uh, Data vision. Okay, data fusion is the process of integrating multiple data source, yes, multiple data source to more consistent, accurate, and useful information than that provided by any individual data source. Okay, so data fusion are often categorized low, intermediate, or high depending on the process stage each fusion takes place. Okay, for example, in this figure you can see some data fusion. Okay, the data can get from some resources, and okay, this data can be combined uh, produce new knowledge, better data, better information from the environment. Okay, thank you. Okay, we can come back to the. Okay, and to save energy, we need to use data fusion and compression. Data fusion and compression. And also transmit and receive. You must know the transmit and receive only if necessary. Transmit and receive data for each node if necessary. And you must know the receiving is just as costly as sending. Okay, so there is no difference. There is no difference between receiving and sending uh, uh, in energy aspect. Another characteristic of WSN is scalability and reliability. Um, WSNs should self-configure and be robust to topology change, because it's possible that this of the node or it's possible to each node can be moved to another location, because there is a mobilizer component for some sensors, and this sensor can change their location. Okay, so the topology can change, uh, and the WSM should self-configure and be robust to topology change, and also maintain connectivity. Yes, we need to okay. Each node in WSM must be connected to the base station. Okay, it can be direct or indirect. Okay, it can be direct or indirect from the pass. Okay, so in all node must be reachable from the base station. And another uh, characteristic is ensure coverage, uh, because we must able to observe all phenomena of interest. Okay, the sink or base stations and interest to the nodes, and okay, we need to able to observe all phenomena interest. Okay, maintenance is another characteristic of WSN. Reprogramming is the only practical kind of maintenance. Uh, okay, and it is highly desirable. Reprogramming is highly desirable. Okay, to reprogram wirelessly. Okay, so okay, the developer need to reprogram wirelessly. Okay, this is another feature of the WLAN. Okay, data collection. Uh, in the WSN, usually we need to send the information from all nodes to the base station. Okay, a centralized data collection puts extra burden on nodes close to the base station. Uh, Again, centralized data collection. Okay, this is there is base station, and all information, all data must be collected in the base station. So um, um, extra burden on nodes close to the base station, because these nodes uh, needs to get the information uh, uh, from the environment, and also need to it must get the data, get the information from the other nodes which are uh, 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 which have more distance to the uh, base station. Okay, please let me to uh, show. Uh, okay, I can draw a figure for this topic. This is base station, and also you know, these two nodes send the data to the base station. Okay, this data can be obtained by uh, uh, these two nodes. Sorry, can be obtained by can be get from the neighbors. Okay, so uh, which uh, have a distance to the base station need to send the data to these nodes. Okay, so uh, these two nodes which are close to the base station, uh, get extra burden in comparison with the with some nodes which have a more distance in comparison to the base station. Okay, this is, we can come back to the file. Clustering is the method which is used in WSN. Data from groups of nodes are fused before being transmitted, so that fewer transmission are needed. Okay, it is called clustering. Often getting measurements from the often getting measurement from a particular area is more important than getting data from each node. Okay, because uh, uh, individual data is more possible to be incorrect, but uh, getting a measurement from a particular area and some data which are sensed by some nodes, and the information can group uh, in a cluster, and uh, okay, this information can fuse to create new and better data from the particular area, and this information sent to the base station. And another uh, another note: security and authenticity should be guaranteed. Security and authenticity should be guaranteed. However, the CPU on the sensing node cannot handle fancy encryption scheme, schemes. Okay, so these are related to data collection. Power supply for the nodes of WSN. AA battery. AA battery is a standard size single cell cylindrical dry batteries. Okay, you can see in this figure. It's called AA battery. You know, the AA battery power the vast majority of existing platform. They dominate the node size because of the size of this battery. Okay, you know, in WSN sometimes we need to use some sensor with lower size. Okay, so okay, so sometimes, okay, we cannot use AA battery because of its size. Another battery is alkaline battery. You can see in this figure, alkaline battery. Alkaline battery offer a high energy density at a cheap price. Okay, you know, the alkaline battery is a type of primary battery with a high energy density and at a cheap price. And another power supply is lithium coin cell, lithium coin cells. You know, these are more compact and both in flat discharge cave. Also, sometimes WSN and sensors nodes in WSN need to use rechargeable batteries. Okay, but who does the recharging? Okay, so some other techniques are used for power supply. For example, solar cell are an option for some application, but is related to is dependent on the application and to the environment. Okay, sometimes it's not possible to use the solar cell. because of the cost, because of the environment. A fuel cell may be an alternative in the future, and okay, one hot research topic is energy scavenging technique. Okay, it's very important because the energy scavenging techniques can increase the lifetime of WSN. Okay, so it is very important for uh, scientists and researchers. Okay, it's related to mechanical, thermodynamical, and electromagnetic science. Okay, another characteristic of WSN radio, usually commercially available chips are used for radio. Okay, with available bands between 433 and 560 megahertz. And also typical transmit power is about 0 dBm. dBm indicate that a power level is dBm indicate that a power level is expressed in decibel. dB is get from decibel with reference to 1 milliwatt. Okay, also the power control is another characteristics of each node. The CPU is very important for WSN nodes. The CPU is very important for any devices, all in for WSN nodes. The microcontroller unit is the primary choice for in-node processing. It's called MCU or microcontroller unit. The power consumption is a key metric in MCU selection. Yes, the power consumption can, it affect the lifetime of WSN. Okay, so it's very important for MCU selection. The MCU should be able to sleep. Should be able to sleep whenever possible, like a radio. Okay, it can use to waste the power, also to save power. Sorry, it can be used to save power, and one feature of CPU can be memory and memory requirement. Okay, but you must know the memory is related to the memory requirements depend on the application. Okay, something we need some application for some application the CPU must um, have more memory. Sometimes, okay, each node need to process some information that get from the environment. Okay, and after that the processes data must be sent to the base station, and sometimes for some application when an event is sensed by the sensor. Okay, the sensor can send appropriate message to the base station immediately. Okay, in this application, okay, the CPU not necessary to have more memory. Okay, with a small memory the CPU can work. Two popular choice for MCU is 80 mega 128 L, and MSP 403. These are two popular choices for CPU of WSN. Okay, do you have any question up to now? Do you have any question? Uh, okay, sensor. The power efficiency of the sensor is also crucial. The power is very important for each node in WSN. Okay, the power efficiency of the sensor is also crucial, as well as their duty cycle. And MEMS technique allow miniaturization. Okay, in this figure, you can see the configuration of the sensor. You know, each sensor enabled by recent advance in MEMS technology. MEMS is get from micro electromechanical systems. Okay, this is the hybrid of some fields, some majors, micro and electronic and mechanical. Okay, are combined in MEMS. Okay, as you can see in this figure, each sensor includes some a battery to supply power, a CPU for processing, memory to save to store information, sensing hardware which are used to uh, uh, get data, get the sense the phenomenon from the environment, and wireless transceiver which is used to connect the sensor to the network. Also, you can see the each sensor integrated wireless transceiver and limited in energy, in computation, storage, transmission range, and bandwidth. In this figure, you can see some other sensor nodes which are presented by some university companies such as UC Berkeley. You can compare the size of each sensor with the coin. Okay, these are some modern. Okay, now I want to talk about the overall architecture of the sensor node. In WSN, in network, uh, some architecture are used in networks such as for example OSI or TCP/IP. In OSI architecture, uh, each end node consists of seven layers. Uh, After OSI architecture, the TCP/IP architecture uh, is introduced. The TCP/IP architecture is very famous and famous architecture in network. You know, each end node in TCP architecture consists of some layers. Can you write the layer? Can you write the name of layers in TCP/IP. Okay. Again, can you write the name of layers in TCP/IP architecture? If you pass the network course, especially in bachelor degree, you must be familiar to TCP/IP architecture. Can anyone write the names of layers in TCP/IP architecture? Okay. For example, application layer. Yes, yes. Physical layer, data link layer, network layer, transport layer. Yes. Thank you. Thank you. Uh, the TCP/IP layer consists of 5 layers. Yes, physical. The presentation is the layer in OSI DUA. Okay, presentation is the name of layer in OSI, not in TCP/IP. The application presentation uh, is combined in TCP/IP. Yes, network layer is another layer, but okay, each layer must process any data that which wants to send in the network. Okay, each layer must process the data. Okay, so and uh, the process each process consume power. Each process consume power. Okay, so in WSN, the number of layers decrease from 5 to 3 layer. Okay, so again in WSN, uh, each sensor node use this architecture, which consists of 3 layers: application layer, network layer, and physical or MAC layer. Okay, the MAC layer is connected to the network and can forward packet on the network. The network layer and MAC layer are the communication subsystems, and application layer is a top layer. And also you must know that the application layer and network layer is related to CPU, not CPU, the sensor, not CPU, and the MAC layer is depend on the radio board. Okay, this is the overall architecture of the sensor node in WSN. Okay, so in this figure, you can see the collection of network sensor. Okay, in this figure, you can see the 10 sensor and one base station. Uh, the nodes are group are group into 3 cluster based on the hop count, based on the hop count. For example, the node 1 and 2 are gathered in the group 1, in the layer 1. this layer is called one hop layer because of the hop count the basis station. You can see the hop count between the node 1 and node 2 to the basis station is 1. Okay, it's called the one hop layer. Some nodes are called two hop layer. Yes, some nodes are called two hop layer. Again, because of the hop count to the basis station. Okay, these nodes, the distance between these nodes to the basis station is 2. Okay, so they group in the two hop layer, and the sensor 9 and 10 are grouped in the 3 hop layer. Okay, this is one architecture to categorize the sensor into some groups. Ali, 9 and 10, okay, number 10 and 9, uh, uh, and these two sensors only sense and observe the phenomenon, okay, and if they find or detect any change according to the interests which is defined by basis station, the number 10 and 9 must send appropriate message to the other nodes in the two hop layer. Okay, so I can say number 10 and 9 uh, cannot cannot see the transmitted signal between some other nodes to the base station, and only these two nodes can uh, observe the environments, observe the phenomenon, okay, and if they detect any appropriate change in the environment, okay, they must send the appropriate signal, appropriate message to the base station. Uh, okay, okay or not? Okay. Um, in this figure, you can compare the network and individual sensors. Uh, by using network sensor, uh, the range of sensing uh, can extend, and we can cover a wider area of operation. Please let me ask a question. Like, can 10 send the info to the other nodes? Yes, 10 get the uh, the number 10 can send must send uh, the information, the message to the uh, to some nodes in the previous layer, in the two hop layer. Okay, it can send the message to some of these nodes, or at least to one node in the previous layer, because the number 10 and 9 must send the message to the base station. Okay, so it must send to the message to the previous layer. Consists of some nodes which are in two hop layer. Okay, Dua? Okay. Welcome. Uh, okay, by using network sensors, okay, we can cover a wider area of operation, and also, multiple nodes close to each other increase fault tolerance, okay, because it's more possible uh, uh, to to get fault information from individuals, but when we use the network sensors, okay, uh, mm, uh, by combining the information from some sensors, okay, we can increase the fault tolerance of the systems, okay. Another advantage of using network sensors is improve accuracy. Sensor nodes collaborate and combine their data to increase the accuracy of sense data and extend the functionality, because in network sensors, sensor nodes can not only perform sensing, okay, not only perform sensing functionality, but also provide forwarding services. Okay, so each node in the WSN must perform two tasks. Uh, First, sensing functionality, and also forwarding services. Okay, because the node must forward the message uh, to the base station. Uh, okay, okay. زي خزر scale. I mean, there is always two nodes close to the base. In this example, uh, in this example, uh, yes, only the node 1 and node 2 uh, are close to the base station. Okay, one of these nodes must get the message uh, from the nodes of in the other layers. In this example, okay, sometimes it can be different, and the number of nodes can be different. Okay, uh, you know, nowadays many applications use wireless and wireless sensor networks. Okay, the application of sensor network can be physical security for military operation. Okay, um, it is very important. Uh, Practical operation of WSN and WSN from some previous years are used in military operation, in indoor and outdoor environmental monitoring. For example, uh, you hear something about a smart home, a smart city, and I don't know, smart grid. Okay, these are some examples of indoor or outdoor environmental monitoring. Industrial automation, biomedical application, health is very important, and okay, no, there are many applications that use WSN for healthcare and health and wellness monitoring, inventory location awareness. A future consumer application including smart homes. These are some examples of sensor networks. in this figure, okay, there are first, you can see the low power networking. Okay, the low power networking is related to WSA, which can be used in, I don't know, in the hospital, in the company, okay, or in a home, okay, in different environment. Low power networking can be used. Okay, in this uh, environment, the WSA can be used with low power networking, and after sensing the uh, information from the environment, this information must be sent on the network, and also this information can send to the internet, a wide area network, and can be used by some applications, some web program. Okay, they can use this information about this gather and collected information, which are stored in the base station, and the base station can come in, and user can monitor the environment, okay, the process information, okay, by base station. Uh, okay. Uh, yes. Any question? Okay. If you agree, we can have a break time for about 10 minutes, and after that, we can continue uh, this concept. Do you agree?